Hello everyone. In this video, I'll be going over rational equations. Okay, first one, just gonna write it. So I have x over 3 plus 5 halves equals 1 half. So the goal of rational equations is to multiply each term by the common denominator to eliminate the denominators and create a linear equation that we can easily solve using our multiplication and addition properties of equality. So here I have 3, 2, and 2. So my common denominator will be 6. So it means I multiply every single term by that common denominator. So think of it as 6 over 1. Even though I'm writing it up high, it's really 6 over 1 times x over 3 plus 6 over 1 times 5 over 2 equals 6 over 1 times 1 over 2. Now I'm going to reduce. So again, I'm thinking of it as 6 over 1 times x over 3, so I can cross cancel. So the 6 and the 3 can both be divided by 3. I'm left with a 2. So 2 over 1 times x over 1, which will just be 2x. Carry down the plus sign. Go to the next term, 6 over 1 times 5 over 2. I can divide both the 6 and the 2 by 2. I'm left with 3. So 3 over 1 times 5 over 1, which is just 15, equals. So the 6 over 2 again reduces down to 3. 3 over 1 times 1 over 1 is just 3 times 1, which is 3. So now I have a nice linear equation, 2x plus 15 equals 3. So now I'm going to minus the 15 on both sides. I get 2x equals negative 12. Divide both sides by 2. And I get an answer of x equals negative 6. Since we have numerical denominators, there's no reason for me to really check my answer into the denominators because there's no way that I could get a denominator that's equal to 0. Okay, so number 2 is just like number 1. I have x over 2 plus 3/5 equals 1/5. So I'm pretty much going to follow the same steps I did with question number 1. Here my LCD ends up being 10. 2, 5, and 5. When I do my prime factorizations, since they're all prime numbers, I'm pretty much just going to multiply them together. So 5 appears once. It does appear twice, but it only gets counted once. So 5 times 2 is 10. So our common denominator is 10. So every single term gets multiplied by 10. Think of it again as 10 over 1. I'm not going to write the 10 over 1 anymore. So cross cancel, divide by 2, divide by 2. I'm left with 5. So 5 times x is 5x. Next term. Divide by 5, divide by 5, I'm left with 2. 2 times 3 is 6. And then again, 10 over 5, both divide by 5. I'm left with 2 times 1, which is 2. So I'm going to subtract the 6 here. 5x equals negative 4. I end up getting the answer of negative 4/5. So it's okay to get a fraction in this instance. Again, especially since I don't have any fractions in my denominator, checking the answer here will not create any denominators of 0, so we don't have to worry about any extraneous solutions. Alright, so number 1, number 2 had just numerical denominators and a single variable in one of the numerators. Let's try one now where I still have numerical denominators, but let's extend our numerators to binomials. And I'm also going to now have subtraction. So we got to be very careful with the subtraction. So I have here 2x minus 3 all over 5 minus 3x plus 2 all over 3 equals negative 2 over 3. So we start off with a common denominator. So our common denominator of 5, 3, and 3 will just be 15. So I'm going to multiply everything, each term, by 15. Now let's reduce. So I have 15 over 1 times 2x minus 3 all over 5. So divide by 5, divide by 5. So with number 1, number 2, I was just taking whatever's left behind and multiplying by the single variable or digit in the numerator. Here I have a binomial. So this 3 is getting multiplied by this entire binomial. So I will eventually have to do some distribution. So I have 3 times 2x minus 3. Carry down that minus sign. 15 over 1 times 3x plus 2 over 3. Divide by 3, divide by 3, I'm left with 5. So same thing, carry down the 5, multiply that by the binomial. Equals 15 over 1 times negative 2 over 3, divide by 3, divide by 3, I'm left with 5. 5 times negative 2 is negative 10. Okay, so again, here's our linear equation. And that's the goal. You want to eliminate the denominators to have a straight linear equation. Distribute. And I have 6x minus 9. Make sure you're carrying over that negative 5. So negative 15x minus 10 equals negative 10. We're going to combine like terms on the left-hand side. So I have 6x minus 15x. That gives me negative 9x minus 10. Nope. And I also have negative 9 minus negative 10, so that gives me negative 19. All equals negative 10. So we're going to combine the 6x minus 15x to get negative 9x. Negative 9 minus 10, negative 19. Add 19, add 19. Negative 9x equals positive 9, because negative 10 plus 19 is positive 9. Divide by negative 9. You get x to equal negative 1. And again, since I don't have any variables in my denominator, I don't have to check the answer per se, but it's still a good idea to do so just to make sure that your solution is a true solution. So you just plug it in, and you would want to see, if the left-hand side eventually does equal negative 2/3. Okay, so that's numerical denominators, but with binomial expressions in the numerator. Okay. Now let's try some that have monomial denominators. So 1 over 3x plus 5 over 6 equals 2 over x. Okay, so my LCD here, I have 3x, 6, and x. So my LCD will be 6x. So I'm going to multiply each term by 6x. Okay, so we're going to reduce. The x's cancel out. 6 over 3, I'm left with 2. So 2 times 1 is 2. Carry down the plus sign. Just the 6's cancel out for the second term. X times 5 is 5x. And for the equals, the right-hand side, just the x cancels out. 6 times 2 is 12. Okay, so 2 plus 5x equals 12. Let's solve for x by first subtracting both sides by 2. We get 5x equals 10. Divide by 5. X equals 2. So we do have variables in our denominator here, so we do want to check to see if we would receive any denominators of 0. So I would take my answer, plug it into any variables in the denominators. So 3 times 2 is 6, and this is just 2. So nowhere here do I have a denominator of 0, so our answer is a true solution. So I don't have to worry about any extraneous solutions. Okay, number 5 is similar. I have here 1 minus 3 over x equals negative 2 over x squared. So watch out with the x squared. That is a little bit different than the ones that we've seen. We're going to think of this 1 as 1 over 1. So my LCD for 1x and x squared will just be x squared. So let's multiply every single term by x squared. So here, since I have a denominator of 1, I can't cancel it down any further. So x squared times 1 is just x squared. X squared over x, we get rid of one of the variables, exponents. So you think again, 2 minus 1 is just 1. So x times 3, 3x. Carry down the minus sign. And then for the equals, the x squares cancel each other out, equals negative 2. Okay, so as soon as you see an x squared, we no longer have a linear equation. We now have a quadratic equation. Quadratic equations must be solved by setting the equation equal to 0 and solving by factoring and using the zero product property. So I'm going to add 2 to both sides to set this equation equal to 0. X squared minus 3x plus 2 equals 0. So we have factoring now. So I have a plus sign here. I have a leading coefficient of 1. So this is straight factoring. So the plus sign at the end tells me this falls into the first category, where our factors of 2 must add to 3. So the only factors of 2 that we have are 1 and 2, which do add to 3. The middle term tells me that the 2 binomials are both going to be negative. So I'm going to have x minus 1 times x minus 2 all equals to 0. So now I'm using my zero product property, so I set both factors equal to 0 and solve. Plus 1 plus 1. I get x equals 1 plus 2 plus 2. X equals 2. And like I said before, you have to check to make sure none of your solutions will create a denominator of 0, which if you plug in 1 here, we get 1 and 1. Plug in 2, 2 and 4. So since both of them do not create denominators of 0, our answer actually is going to be both variable solutions. So x equals 1 or x equals 2. Both of those numbers would satisfy this equation. Okay. So there's 4 and 5. We have monomial denominators. Let's move now into polynomial denominators, primarily binomials. So I have x over x minus 5 plus 5 over 2 equals x times x minus 5. Okay. So here is number 6. So LCD is the same thing as least common multiple, and least common multiple states that we must find the smallest value that all terms share. So basically the way I was explaining it in class is your LCD / least common multiple will be all pieces of all denominators. Any repeats are only included once. So I am only going to include the x minus 5 once, but I also have to include the 2. So my common denominator for number 6 will be 2 times x minus 5. So now I'm going to multiply each term by 2 times x minus 5. These are the examples where it's going to start to become more complicated. So x minus 5 removes. I have 2 times x left. 2x. Carry down that plus sign. Now I only have a 2's removing for the second term. So the 5 is getting multiplied by x minus 5 equals. X minus 5 cancels. 2 times 5 is 10. Distribute 2x plus 5x minus 25 equals 10. Combine like terms. 7x minus 25 equals 10. So now we're going to solve for x by first adding 25 to both sides. 7x equals 35. Divide by 7, divide by 7. I get x to equal 5. Okay, so I have a solution. But now I got to see if my solution will create any denominators of 0. And look what happens here. When I plug in x equals 5 to the first denominator and the second denominator, I do end up getting a value of 0. So that means that x equals 5 is considered to be an extraneous solution, and we cannot keep it. So we have to reject it. So again, reject solution because creates a denominator of 0. So if you reject your only solution, what is then going to be your solution? Your solution is then going to be no solution. If you had 2 answers there and you reject only one, of course the one that does work would be your solution. But it's possible to have 2 solutions like we saw in example number 5. We can have 1 solution like all the other ones we've seen, 1 through 4. Or here with number 6 we have no solution. So that could happen. Okay, number 7. X over x squared minus 4 minus 2 over x minus 2 equals 1 over x plus 2. Okay, so with number 7, I have a Dopp's expression, difference of perfect squares. So I have to factor that expression first to figure out my common denominator. So I factor Dopp's to binomials. One will be plus, one will be minus. The first term in each binomial comes from what item would multiply by itself to get x squared, which is x. And the second term in each binomial comes from what number multiplied by itself gives you 4. And that is 2. So basically now I'm going to ignore the x squared minus 4 because now the denominator is x plus 2 times x plus 2 times x minus 2. Okay, so everything is factored. Now I can figure out my common denominator. So again, common denominator must be all pieces of all denominators present. So I have x plus 2 twice, x minus 2 twice. So that will be my common denominator. Don't include any doubles, you just include each double once. So let's multiply each term by the common denominator of x plus 2 times x minus 2. And we're starting to move into the more complex examples. For the first term, the denominator completely gets canceled out. I'm left with just x. Carry down the minus sign. Second term, the x minus 2 cancels, so the 2 that's left behind gets multiplied by x plus 2 equals. For the last term, the x plus 2's cancel out. The 1 gets multiplied by x minus 2, so it's just x minus 2. Come back over here and distribute on the left-hand side. So x minus 2x minus 4 equals x minus 2. Combine like terms. 1x minus 2x equals negative 1x. Minus 4 equals x minus 2. All right, let's solve for x. So I'm going to move the x to the left, the 4 to the right. So minus x, and I'm going to do the plus 4 in the same step, just to save space. So negative 2x equals 2, and negative 1 minus 1 is negative 2, negative 2 plus 4 is positive 2. Divide by negative 2, x equals negative 1. So I boxed my answer off, but let's just double check to make sure. So here, negative 1 squared is 1, minus 4 is negative 3. Negative 1 minus 2 is negative 3. Negative 1 plus 2 is positive 1. So no denominators of 0, so we can say that x equals negative 1 is our true solution. So 7, we have monomial expressions in our denominators. All the denominators, I should say. Okay, number 8. Let's see if we can squeeze it down here. So I have x over x plus 4 minus 1 over x plus 2 equals 8 over x squared plus 6x plus 8. Okay, so just like with example number 7, I need to factor the trinomial. So I have a plus sign at the end, I have a leading coefficient of 1, this is standard factoring. So plus sign means I'm going to add the product, the factors of 8 to the middle term. So I get 2 and 4. Middle term is positive, so that means both of them will be positive. So x plus 2 times x plus 4. So just like with example number 7, my LCD ends up being all of the common pieces. So I have x plus 4, x plus 2, x plus 2 times x plus 4. So we'll say the LCD is x plus 2 times x plus 4. It's possible to have gotten 3 different denominators. If, say, this was a different, say it was x plus 2 and x plus 6, just saying. I would say my denominator then is, my common denominator is x plus 2, since it shares the x plus 4 and the x plus 6. So keep that in mind that you can have 3 binomials multiplied together, factors, be the common denominator. It's not that common, but it could happen. Okay, so I'm multiplying each term by the common denominator of x plus 2 times x plus 4. And we're going to eliminate the shared items to get rid of the denominators. So first term, x plus 4 goes away. So I have x times x plus 2. Carry down the minus sign. X plus 2 goes away. So 1 times x plus 4 equals, here the denominator cancels out everything, top and bottom, so I'm left with just 8. Distribute, x squared plus 2x minus 4 equals 8. Let's combine like terms. Oh, this is supposed to be plus 2x, excuse me. So x squared plus 2x minus 4. Combine like terms. So just the 2 x's. So x squared plus x minus 4 equals 8. I have here that x squared term, so I have to solve this quadratic equation through factoring. So I'm going to minus the 8 over. And I'm getting x squared plus x minus 12 equals 0. Okay, so now I need to factor this guy. So it's minus at the end, leading coefficient of 1, so standard factoring. Minus means we subtract the factors of 12 until we get one that equals 1. So 1 and 12, 2 and 6, 3 and 4. 3 and 4 are the two factors that subtract to 1. The middle term is positive, which means that the larger number here will be positive. So that means I'm going to have x minus 3 times x plus 4 equals 0. Let's use our zero product property and set each factor equal to 0 and solve for x. I get x equals 3 and x equals negative 4. Now we have to check our solutions. When I plug 3 in, I get 7, 5, 9, plus 18, plus 8. Well, I know that's not going to equal 0, so I don't really have to find the sum. So 3 is okay, so we can box that one off. Now let's go to negative 4. Negative 4 plus 4 is 0. Oh, right away. Creates the value of 0. We reject it. So I said before, you can have two solutions, reject one, keep the other one. You can have two solutions, keep both solutions, have one solution, and reject that one solution, have no solution. So it's possible to have no solution, one solution, or two solutions. So for number 8, our answer is x equals 3. Okay, so 8 dealt with binomial and trinomial denominators. The last two examples can be solved a little differently, and that's primarily because of the way they are set up. So number 9, I have 4 over x minus 5 equals 4 thirds. So here I have a rational expression equals a rational number. So two fractions equal to one another. So I can do here that cross multiplication that we talked about. So anytime that you have two fractions equal to one another, no matter what the denominators may be, as long as it's a standard fraction equals a standard fraction, you can cross multiply. So cross multiplication again stated that if a over b equals c over d, therefore a times d equals b times c. So I'm going to do 4 times 3 equals x minus 5 times 4. So now we're going to simplify. 4 times 3 is 12. Distribute, distribute. I get equals 4x minus 20. So now I have a linear equation that I can solve for x by adding the 20 over to the left. I get 32 equals 4x. Divide by 4. And then x will equal 8. And just like with any of the rational equations, you want to make sure that your answer does not create a denominator of 0, which it does not. 8 minus 5, is 3. So x equals 8 is our answer. Okay, my last example. I have a plus 2 all over a squared plus 3a. Pen's starting to run out of ink because we switched to black. Equals negative 2 all over a squared minus 9. So I have, even though I have all these crazy binomials, I can do cross multiplication here. So it's going to be a little more complex, so bear with me. So I'm going to do a plus 2 times a squared minus 9 equals a squared plus 3a times negative 2. So on the left-hand side, I do have to do some FOIL. A times a squared is a cubed. A times negative 9 is negative 9a. 2 times a squared is 2a squared. And 2 times negative 9 is negative 18. So rewriting this in descending order, a cubed plus 2a squared minus 9a minus 18. And then over here on the right-hand side, distribute, I get negative 2a squared minus 6a. So even though I do have a cube term, I'm going to treat this like a quadratic equation. So I am going to add the 2a squared and add the 6a. And now I have a cubed plus 4a squared minus 3a minus 18 equals 0. Okay, so remember, quadratic equations we can solve using factoring and the zero product property. We can't do that here because we have 4 terms. So I'm actually going to try to see if I can factor this using factor by grouping. I'm not sure if it's going to work. So let's see what happens. So over here I'm going to take away a squared. Okay, so that's what I'm left with. Over here I'm going to take away negative 3. Okay, so that really didn't work well. Just checking my steps here. Okay, this happens. So this one, even though we tried using the cross multiplication, it started to become a little too chaotic. So let's rework this problem with the previous method. So I'm just going to rewrite this problem. Let's see if we get a better answer. And that's part of math, trial and error. Sometimes the method you think would work does not work. Alright, so I'm going to dops out a squared minus 9. This has a GCF of a. So my common denominator is a times a plus 3 times a minus 3. So I'm going to multiply both sides of the equal sign by that. Let's see what happens now when we do this. So on the left side, the a and the a plus 3 cancels out. I'm left with a plus 2 times a minus 3 equals. Over here, the a plus 3 and the a minus 3 cancels. I'm left with negative 2a. So use FOIL on the left-hand side. I get a squared minus 3a plus 2a minus 6 equals negative 2a. Combine like terms. A squared minus 1a minus 6 equals negative 2a. So now I have a nice quadratic equation. So let's add the 2a over. A squared plus 1a minus 6 equals 0. I can factor this to a plus 3 times a minus 2. And when I use the zero factor property, I get a to equal negative 3 and a equals 2. Let's check our solutions. Let's see, if I plug in negative 3 on the original right-hand side, negative 3 squared is 9. That gives me a value of 0, so I reject that. Same thing would happen over here. Negative 3 squared is 9. 3 times negative 3 is negative 9, also give me a 0. So my solution here would only be a equals 2. So that's the correct work. So that was using the old method. So if we had a little bit of an easier expression here, the cross multiplication probably would have worked out better. I might have made a silly mistake, so please don't worry about that. But better way to do that question, if that was to happen, if you're struggling and you're not getting it to work right, you want to do the work we did here, which was to go back to the old method of multiply both sides by the common denominator and cross out the denominators. So I hope this video helps you understand rational equations. Thanks for joining me today.